What's up, Harold? Oh, I'm sorry, I forgot. Yeah. Guys, does anybody else need a copy of the pay quiz? All right, guys, I'll start filling in the key, and then we'll stop if you have questions on things.
Can you also post the key on forum as well?
It is already, and I'm recording this, and I'll post this too. Okay? Yes.
Yeah.
I know that one threw you off. You didn't like the period being something without a pi, but it is. A couple of choices on your phase shift here. You could have done right pi over 3. You could have done left 5 pi over 3. Don't use positives and negatives because some people are like, well, it went to the right, so I put negative because it's the opposite of what it means. And other people are like, it went left, so I put negative. So I don't know that you know what you mean. If you do an arrow, I know exactly what you mean. Assuming you know your right and lefts and all that stuff.
So we shouldn't say like right.
You can write the word right and left. That's totally fine. Don't just put a plus or a minus. This one, the shift, if you saw it flipped, then you went right pi over 6. Okay? If you were like, no, I'm not flipping this, then a couple other things you could have done. You could have done left pi over 3 or right pi over 3. Sorry, 2 pi over 3. Lots of choices there. Yeah. The first one? Which one? Sorry. This one? The third one? Right pi over 3 or left 5 pi over 3. The sign is normally at 0, 0, right? And so it is shifted right and down if you look at that point. Each tick mark is pi over 6. So it's gone 2 tick marks over, so it's gone pi over 3. That is 5 pi over 3. Yeah, because if you're all the way over here, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 6, which is the same as 5 pi over 3. Yep. Any questions on those top two? Because I'm going to scroll down. All right, now these two at the bottom, cosecant and cotangent, guys, those have asymptotes that go to infinity, right? They technically don't have amplitude. They still have a vertical stretch, all of that, but there's not a measurable height because it goes to infinity. The graph goes to infinity. So you would just say none for both of those on the amplitude part, okay? Scroll down. And then be careful, period of cotangent, remember, is pi over b, not 2 pi over b. All right, we'll pause there for a second. Any questions? Yeah. I'm sorry, if it's 6 pi what? So the pi. That makes sense. And same with like when you pull that out. All right, questions before we go to the next page. All right, so writing the equation here, this first one, I think the easiest way to see it is just as flipped cosine, so a negative stretched by 2 cosine of 4x, because the period there is pi over 2. The second one, I see it as negative sign. You could certainly do it without that. Your shift would just be different. And the b value is 1/2 x minus pi over 4 and plus 2 at the end. Guys, when I ask you to write an equation, please, please, please put the y equals so I don't have to be mean and take a half point off, okay? Don't make me do that. Yeah, Mom. 2b, sure. So do it a piece at a time, okay? So let's just erase this and we'll start back at the beginning. There's your midline, right? And then there's, well, almost. There's the maximum. The amplitude, or that a value, is the distance midline to height. So what is the amplitude? No. How far is it? From 2 to 5. There you go. Okay. All right, normally your sine curve starts at 0, 0, and then goes up, right? So are you okay with seeing this as negative? Okay, good. We know there's a b value. I'm going to save that for the end, though, okay? So phase shift. Again, normally sine starts at 0, 0. This dot is now over pi over 4. So how would you write the phase shift? What is the shift? How far right did I go? To get from
Pi over 4?
Yeah, pi over 4. So we're just going to say x minus pi over 4. Okay. And then remember, your vertical shift matches your midline. So what is the vertical shift? Yep, so plus 2 at the end. So then the only thing we have left is the period. This is showing you one complete cycle of the graph, okay? Like from this point to this point. Do you see how that's a complete graph? Yes. How far is it between those two? And you would find that just by subtracting. So what's 17 pi over 4 minus pi over 4? Yeah, and what's 16 pi over 4 reduced to? Okay, so the period is 4 pi. Remember, the period is also 2 pi over b, and the b is what we need in the equation. So however you want to solve that, if you can just visualize what b should be, great. If you want to multiply both sides by b, and then divide, what do we end up with for b? And that goes right in there. Okay? Baby steps. One thing at a time, guys. Okay? Sure. So, let's have some room here. Normally, sine starts on the midline, like starts at 0, 0, right? It's been shifted to here. Like, do you see how that's the dot that has moved? Okay, so we know it's gone up 2. That's fine. And then it's only gone to the right pi over 4. That's it. That's all we're doing there. Okay? Harry? It didn't flip? Okay. So then almost everything is the same. but you have to figure out what that point is.
I would distribute x and then minus 1 pi.
Okay. Yes, because this is right 9 pi over 4. I would just leave it in factored form. Your distribution is correct. Like your answer would be right. Leave it in factored form because then it's easy to see here's the b, here's the phase shift, and you're not going to make a silly mistake distributing. We don't need those, right? Yeah. Yeah, that's what you always do to find distance. You do like one endpoint minus the other endpoint. Yep. We okay? Okay. If we have time at the end, we'll definitely do some more writing the equation from the graph. Okay. All right. Let me put your answers in here. I know the 2 pi was in there. Like it works out fine for this one. I would not use it on this one, or this one, or this one. On your test, it will just be a blank grid. You can label it how you need to label it, okay? But on your test, if you don't label your axes, you are losing a decent amount of points because then I can't tell what the period is. I can't tell what you shifted by, any of that, okay?
We have to label like every single point. We label like every other.
No, because if you're skipping points, like if the period's weird, say the period's 2 pi over 3, I don't know if you're skipping every other one because you're just skipping it or because you don't actually know what the label should be. Okay, so label all of them. And label on your y-axis here as well. So let's see.
The graphs on the test when you yes.
No, way bigger, much easier. Yeah. Yes, yes. Plenty of room, labels, you'll be able to get it all in there. Okay. Let's see, this one shifted down 3, right? So we were down at -1. This is a lot of red on here, sorry. So we got this guy. And then we were at -1 on this one. You guys see that okay? We okay with that graph? Oops, sorry, that's fine. Switch colors.
That means just like one is simpler or like 2 is
So if you're drawing one period, like this is one period of the graph. That's fine. I'm just doing the whole thing just because if you draw more than one period, I'm not going to be like, minus 17, you drew more. No. So this one, because tangent's flipped, it looks a lot like cotangent. But obviously your asymptotes are in a different spot. Yeah. Which one, sorry? D, sure. So tangent normally, go down here. Let me draw the parent graph. So normal tangent goes through 0, 0, up to 1 asymptote, okay? So that's your parent graph for tangent, okay? The negative out in front is flipping it over the x-axis. So that is making it go this direction instead. It's making it go the direction of cotangent. Okay, then the last piece is just to shift it up to. They stay in the exact same spot because flipping those doesn't do anything. Undefined is still, like multiplying that by a negative, it's still undefined. What? Like on the graph, or do you mean without graph? So you have to think about where cosine is equal to 0. So go through like here and here, right, is where cosine is equal to 0. So you know it has to happen at pi over 2 or 3 pi over 2. And then you have to think about like setting this equal to pi over 2 or 3 pi over 2. It's kind of messy. I actually think it's easier to just sort of sketch the graph, even just sketch the cosine graph of it and go, oh, okay, there's where my midline points are. That's where the asymptote should be. All right. Anything else on the graphs? Okay, let's keep going. Let's go back to the stuff from the beginning of the unit. Did you guys like forget that this part even existed for this unit? Yeah, okay. All right, let me jot the answers, and then if you need me to go through any of them, I will. I definitely want to talk about 4. And we'll talk about 8. Yeah. I would not do that. I want, if this is given to you in radians, I want answers in radians. and then converted it back to radians at the end?
Like,
So your answers were in degrees? Yes, I would take points off. Yep, if it's given in radians, I want radians. And honestly, it takes way more time to convert that to degrees than to just go, right? I mean, you're just adding 2 pi over 1, so you're really adding 14 pi over 7, or you're subtracting 14 pi over 7. Like, that's way faster than converting. Okay, so do that. Save yourself time. Remember, you need to be efficient. Eli.
The reference angle is between the x-axis and the
Yes. And guys, the reference angle must be positive and acute. Okay? So if you need to make a picture, do that. If you, like, you've got to visualize it. It's got to be between 0 and 90 degrees, okay? If you end up giving me, I don't know, if you told me like, oh, the reference angle is 2 pi over 3. No, it's not, because that's not a first quadrant angle. And I could ask you reference angles that aren't from your unit circle. Okay, I could ask you like, what's the reference angle for 17 pi over 12? You know, I can ask you weird things like that. The process is still the same. Sure. Yeah, I scrolled down kind of quickly. Yeah, Kara. 7, sure. Give me just a second. Hold on, Gretel. Yeah. You're good? Okay. 7 first. All right. So cosecant of 5 pi over 4. Think about where 5 pi over 4 is. It is down here, right? Do you know your ordered pair for that point? Okay. So we care about the y value this time, but they're the same number, so it doesn't actually matter. But we want the cosecant of it. So guys, little cheat sheet for you here. If you start with the ordered pair value of root 2 over 2, every time you flip it, you end up with just root 2, okay? You shouldn't have to go through every time going, okay, 2 over root 2, and let me rationalize, and okay, 2 root 2. Oh, I got root 2. Every single time you're going to get root 2. Just like every time you start with a half, when you flip it, you get 2. If you start with root 3 over 2, when you flip it, it is 2 root 3 over 3 every time. 1 flipped is 1. 0 flipped is undefined. Come on. I'll show you a tangent shortcut thing here too. So, does this make sense, guys, what I'm saying? Like, you should just get familiar enough with those values that you aren't like rationalizing every single time that you have to do one of those. Let me show you the tangent ones real quick, and then we'll go back to number 7, okay? So if I have tangent of any of the over 6s, so like pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, any of those, it's always going to be root 3 over 3. You have to decide, is it positive or negative? Okay? If it's an over 4, it's always positive or negative 1. If it's an over 3, it's always positive or negative root 3. And then if you do the cotangent of the over 3's equal the root 3 over 3. Over 4's are the same, and then this is the over 6's. So if I ask you tangent of, 5 pi over 3, you know it's going to be root 3. You just need to figure out positive or negative. Okay? You don't have to sit there every single time and go, okay, let me do root 3 over 2 divided by 1/2, and flip and multiply and rationalize. Like, you don't have to do that. Those are the only answers you're going to get. Okay? So jot that down, take a picture, whatever you need with that. Okay. Do you need this one too? Sure. I see some people taking it. So you have to find where it is so you know if it's positive or negative. But if it's an over 6, it's always going to be root 3 over 3. You just figure out positive or negative. Okay? There's the tangent one again. No, this is just any time, like, this is the sine or the cosine. This is the cosecant or secant. Like, that's the flipping. Okay. Okay, let's finish number 7 now. Okay, so we've got 2, and then we know now if I flip negative root 2 over 2, it's just negative root 2. Okay. Then sine of 5 pi over 3, so you go, okay, 2 pi, 4 pi, that's right here. What is the y value down there? So that is your answer. Like, you could just leave it as negative 2 root 2 minus root 3 over 2. Or if you did a common denominator, it'd be negative 4 root 2 minus root 3 over 2. Yep, either one of those works. Greta, do you have a different one you want me to go over? 4 and 5. Can you see that okay here? Okay. So reference angle. Do you know where negative 5 pi over 3 is? Like which quadrant it's in? It is in quadrant 1, because this would be negative pi over 3, negative 2 pi over 3, negative 4 pi over 3. There's where negative 5 pi over 3 is. The reference angle is the first quadrant angle that corresponds to that. If you had ended up with something like, I said, what did I say before, like 7 pi over 12. If I want the reference angle of that, where is 7 pi over 12, guys? What quadrant is that in? 2. Think through this. This is normally pi. This is normally pi over 2. If I'm thinking of that in terms of something over 12, this pi over 2, couldn't that really be 6 pi over 12? And pi could really be 12 pi over 12. Like, you got to be comfortable with fractions here. So 7 pi over 12 is somewhere in here. I need to know how far is it from the x-axis. So how far is it from 7 pi over 12 to 12 pi over 12? A lot of 12s, yeah. So your reference angle is 5 pi over 12. Does that make sense? Okay. And then you said 5 also? Okay. So a positive and a negative coterminal angle, that means if it's in radians, you're just adding 2 pi or subtracting 2 pi. So I'll go through it again here. Your angle is negative 4 pi over 7. You are adding and subtracting 2 pi. So you just need a common denominator to do that. So 4 pi over 7, and that would be 14 pi over 7. So negative 4 pi plus 14 pi is 10 pi over 7. Negative 4 pi minus 14 pi is negative 18 pi over 7. Okay. If it's in radians, I want radian answers. If it's in degrees, I want degree answers. Okay? Anything else before the last page here? Oh, the bottom, guys. I didn't explain that one. Some of you, I know, walking around and looking at yours, you talked about, like, I know what the sine of 45 degrees in and made a comparison there. Even if you don't know anything about trig, just hold on, Dave, I'll call you in a second here. We know sine of an angle is opposite over hypotenuse, right? What do we know about the hypotenuse in a triangle? It's the longest side. If you're doing a shorter side over a longer side, it's never going to be bigger than 1, right? Okay, so just your basic geometry knowledge is all you really needed to answer that one. Okay. Were you just going to answer for me? Or? Okay, all right. All right, last page. These are the ones where you need to draw the triangle and make sure you've got it in the right quadrant. This one, we were talking about a 4th quadrant angle. That's where secant is positive and cotangent is negative. So you end up with negative 3/5 for sine, 4/5 for cosine, negative 3/4 for tangent, negative 5/3, positive 5/4, and negative 4/3. This one then, you plot where that point is, negative 2, 3. That's the 2nd quadrant here. You have to use the Pythagorean theorem to find your hypotenuse. That ends up being root 13. So you need to rationalize your answers. You end up with 3 root 13 over 13 for sine. Cosine is negative 2 root 13 over 13. Tangent is negative 3/2. Now, guys, when you go to do cosecant, don't take your rationalized sine and then flip it, because that's going to just make way more work for you. I know it's the reciprocal of sine, so instead of opposite over hypotenuse, just put hypotenuse over opposite, and it's just root 13 over 3. Like, there's no work you have to do on that, okay? And then this would be negative root 13 over 2, and your last one is negative 2/3. Come on.
You were able to draw that triangle because they used 2 points like X and Y and negative 2 and 3.
Yeah, because I know where negative 2, 3 is. Like, I know that dot. That is the end of my triangle. Yep. Because the X is negative 2, the Y is 3.
So if they didn't give you like the Y, how would you know? Would you be able to?
If they didn't give you the Y,
Yeah, say with any.
that's not enough. You have to have at least 2 of the sides of your triangle. Here. Quadrant, which one? 9 or 10? 10? So if I were to plot the point negative 2, 3, where would that be? Yep. Because that's left 2, up 3, so you know where you are. Yes. Don't make it harder than it is, okay? Yeah.
You know the quadrant for another time.
Okay, so secant, that I know is like cosine, and that's positive. This is x values. I know that I only have positive x values in the 1st and 4th quadrant. Okay, because this is that, right?
Yeah.
Then I take that information and go, okay, and I need cotangent to be negative. 1st quadrant, nothing is negative, so it's not going to be there. So it's got to be the 4th quadrant. Because cotangent, remember, is x over y.
Yeah.
Okay. Yeah. All right, then some special right stuff down here. 4 inches, 10 root 3 centimeters, 4 root 2 feet, 4 root 3 yards. And when you complete the square, you get 1 or negative 7/3. Okay. Questions? Yeah. That one does factor, yes.
But you show how you complete this.
Yes, I can. So I'm going to move the 7 over. Okay. We have a leading coefficient this time, and I don't want that, so I need to divide everything by 3. You okay with that? All right, then you take this b value, this 4/3, you divide it by 2, and you square it. So what is 4/3 divided by 2? 2/3. Remember, that's like 2/1. Dividing by 2 is same as multiplying by 1/2. Okay, so 2/3, and then 2/3 squared, 4/9. I am adding 4/9 to both sides of this equation. Okay, then I can factor this. You're always going to have an x. It's your sign from your b value up above, and then it's the square root of that last number. So of 4/9, that would be 2/3 squared. Okay, over here I've got to add 7/3 plus 4/9. So yeah, because I'm going to make that 21/9. Good. Okay, with me there? Then it's just a matter of solving. So I square root both sides. I get plus or minus 5/3. And then you actually just add and subtract those numbers, and you get -2 plus 5 is 3/3, which is 1, and then -7/3. Okay? So if the directions say solve by completing the square and you don't complete the square, you won't get credit for it. Yep, solve whatever works for you. Definitely. Other questions? Let's see, how much time do we have? Yeah. 12? All right. Let me draw a bigger picture than what I have room for on there, okay? So you've got a 30, 60, 90 triangle. And they say the leg opposite the 60-degree angle is 15. And they want to know the hypotenuse, okay? Remember, long leg is equal to √3 times short leg. I know the long leg's 15. I don't know the short leg. So I have to solve this. Rationalize, you get 15 √3 over 3, which is 5 √3. Are you with me there? Okay, so that's this side. How do I go from short leg to hypotenuse? Yeah, multiply by 2. So this ends up just being 10 √3. Okay. Other questions, guys? How what? I'm sorry. It's always hypotenuse is 2 times short leg. So these are kind of the two equations you need for a 30, 60, 90 triangle. Anything else, guys? Okay, do you want to do a few practice problems, or do you want the last few minutes to work on your delta math and stuff? Practice problems? Okay, let's do some write the equation of the graph kind of practice problems. Yes. Neil, do you have a question? Do you have a question?
I was just curious when this class ends.
It ends at 11:19.
And then, is there like, so for the grab and go lunch, is there other buses that we can take while they get here?
So 8th period ends at 12:24, and I feel like buses come at like 12:55 or something, like 2 hours before when we normally get out. Yes. You walking home today? Is it what? I'm sorry. With the fake quiz, yes. Like, there's a couple of the converting ones. They were only weird ones that, like, you needed a calculator for. So there's a couple things like that that are on the fake quiz that aren't on the Delta Math.
But we're not going to use
No calculator.
Maybe question.
Yeah, go ahead. All right, guys, so I will give you the graph. I'll label a couple of points for you. I want you to write a sine equation, and I want you to write a cosine equation for this. Both. Yeah, you can do it on a whiteboard if you want. You can do it on your own paper. It's up to you.
There we go.
You gotta do both. Yeah. Yeah, great. And there's several ways. Like I could ask you for 2 of each, or really like 4 of each. I'm not gonna do that, but lots of ways you can do this. If you think you've got it, you can hold it up and I'll check you. Would you like for us this? Your cosine looks good. Your sine, you're close. Your phase shift is off.
Okay.
Hold on, let me think about your sine one because I went right, not left. I think you're good. I need both, and you don't have everything there yet. You're good, Oliver. Yeah. There's a phase shift with cosine. Your phase shift is off in your sine. You didn't write a cosine one yet. Let's see. I think your phase shift is wrong in sine, but I'm not gonna lie, I can't actually read that number. I think it says 7 pi over 6, but is that wrong? Oh, 5 pi over 6 or 5 pi over 3? There's an amplitude for sine also, and no. Hey guys, let me do it up here because I think it's going to take me a while to check everyone. So 19. Got a little bit of time. Okay guys, let's look at this. Which do you think is easier, sine or cosine? I think cosine is what you see right away. Like that to me looks like, right, normally cosine is here. Actually here, but so it's gone up and over. So I see the cosine first, but it's okay if you're like, no, I see sine. Good for you. Let's write the cosine one though first. Please, please, please put your y equals. Okay, the maximum is here at 4. Where is the midline? 2. Okay, that distance, that's your amplitude. So what's your A value? 2. All right. This is pi over 6. This is 7 pi over 6. How far is that? 6 pi over 6, which is really pi, right? So I have to go another 6 pi over 6 to get over here. Okay? A normal 2 pi period, so there is no b value. So we just have to look at our shift. Normally cosine starts on the y-axis. It has moved over here. Like that maximum value is normally on the y-axis. So I see right by pi over 6. There are other ways to do it, but I think that's the easiest one to shift to. And then your vertical translation, that's where the midline is. So do you guys see that we've shifted up 2? And that's your cosine equation. Once you've figured all of that out for cosine, turning it into sine, the only thing that's going to be different is your phase shift. Okay? So, two ways you could do it. You can see it as flipped sine. That's what I saw it as, because I'm envisioning this point as being the one that's normally at 0, 0. And after that point, it went down instead of up. So I see a -2. Okay, figuring out how far you have shifted. Let me erase some of this stuff. I did not label those points in the middle there for you. What do you know about them? Oliver? Exactly. They're going to be exactly halfway between your maximum and your minimum. Okay, so if this is at pi over 6, and this is at 7 pi over 6, what's halfway in between?
Pi over 3.
2 pi over 3, right? Because it'd be 4 pi over 6. So this one's at 2 pi over 3. So I see shifting to the right by 2 pi over 3, and then your vertical shift is still the same. If you were to what? Oh, sure. Yeah, so it's then, oops, make that positive, like 5 pi over 3. Okay. Yeah.
Could you also do plus pi over 3?
You could have done plus pi over 3 and gone this way
Yeah.
and had a positive 2. Yes. Okay. Let's do another one, guys. That point in the middle is pi 2. I want you to write a tangent and a cotangent. Hold on, let me get attendance taken before the bell rings.
Yeah,
Hold on, I'm taking attendance. Guys, check with your neighbors, see if you agree. And then we'll go through it up here in a minute. You're very close. Make sure you do your y equals. Yes. Yes. Oh, good. Do you have a negative in front of your cotangent?
Yeah.
Good. Yeah. Okay, I would leave it factored, but you're not wrong on the one you distributed. Same, I'd just leave it factored so that you don't make a mistake somewhere in there. Yeah, that's good. No, there is a b value, and there's not a shift with the cotangent one. All right, guys, let me go through them. Sorry, let's go through them. All right, the direction it's going looks like regular tangent, but it's definitely been shifted, okay? So I'll do tangent first. Tangent normally goes through the point 0, 0. That's like your center point of your graph. That is now this point. So we know that we've gone right by pi and up 2. Is everybody okay with there's no vertical stretch happening here? Okay. The period of this one. What is the period normally for tangent? Yeah, it's pi over b, and it's regularly just pi on the parent graph. If this point in the middle here is pi, the period of this graph is now 2 pi. So you have to think about pi over b equals 2 pi. What does b have to equal? 1/2. So there is your tangent equation. For cotangent, it's going the opposite direction, right? Cotangent normally would be going this way. Okay? So we know we have a negative in front. 1/2 x. But guys, there's no phase shift here. The asymptotes are in the right spot. There is a vertical shift up 2. Okay? Questions on that one? Are we feeling a little bit better about writing equations? Okay. I'll put one more up here if you guys want to practice it. I don't know that we'll have time to go through it, but just so you've got another one. you want to try one more. I know we're going to run out of time. So you could write this as a secant and a cosecant. Does that say 1/2 x or 1/3? Why are you getting 1/3? Because this would be pi. Oh, I'm sorry, I lied. Yes, it would be. This would be 3 pi over 2. Right. Hold on. Let's see. And then this would be negative 3 pi over 2. Yeah, because the period is 6 pi. So yes, good job. Yes, I'm making them as we speak. I think it one is the easier one. All right, guys. Saturday. Okay. And I just haven't done the cosecant one, but it would be shifted either left or right by 3 pi over 2, depending on if you flip or not. Okay. Bye, guys.
I got a video on my quiz.
I
thought I failed.
Hey.